All right, welcome to our notes for Unit 2 on the topic of chemistry, the study of matter. We know that chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. So in this chapter, we're going to look at what things are made of, how to separate items from other materials, and to get them into what we want. For a chair, a book, a computer, a calculator, any of those items, we have to get those materials into their pure substance and then combine them with others. So one of the terms, this is a kind of a big chapter for vocabulary. Matter, of course, is anything that has mass and takes up space. So air is still matter. Some examples of things that wouldn't be matter would be the different types of energy like heat and light and radio waves and stuff like that, but it's pretty hard to think of something that isn't matter. Now, density is one way that we separate lots of different types of matter, and we would take the mass divided by the volume. In chemistry, we usually use grams divided by milliliters, and 1 milliliter just happens to be the same size as 1 cubic centimeter. So you can use milliliters with a graduated cylinder, or you can find a ruler and use the length times width times height to get cubic centimeters. And there's a couple of different ways of rearranging the same formula. So a little bit of basic algebra there. You can find density, or you can find the mass, or you can find the volume, as long as we have two of those numbers. So let's go down to here. Let's see. Now, there's lots of different types of changes. There's physical changes, and there's chemical changes. For a physical change, doesn't matter what the substance is, you're going to have the same type of material. One would be cutting, another would be melting and dissolving, and it's still the same material. So think of all the things you can do with water. It would of course have the same density, no matter how big of a piece of sample or how much water you have. If you divide the mass by the volume of water, you'll always get the same density. If you cut it, it'll still be water. If you dissolve it, it'll still be water. So there's a lot of physical changes. Now, with the chemical change means that it's a completely different substance. So burning, like paper burning, iron rusting, eating food, decomposing, it's no longer the same chemical formula. So going back to water, it would be pretty difficult to think of how to chemically change water because it's H2O. In order to chemically change it, it couldn't be H2O anymore, but we could use electricity, electrolysis, and split it into hydrogen and oxygen. That would be one type of chemical change that you could do to water. Now, another bit of material we need to know is the classes of matter. So I'm going to show you a little chart for the vocabulary for the remainder of the chapter. It's going to show how everything is branched. So matter is split off into mixtures and pure substances. And from there we have homogeneous or homogeneous, heterogeneous, and then the pure substances branch off as well. So I'm going to go back up and explain some of those different topics and give a few examples. First of all, mixture. Here's the technical definition. One easy way to tell that you have a mixture is that there is no chemical formula. Like H2O is not a mixture. It has a chemical formula. Milk is a mixture. There's no chemical formula for milk. And from mixture, we have two different types. We have homogeneous or homogeneous. Means it's the same throughout. So milk is typically homogenized. And you'll even see it on the bottle of milk. It says homogenized. A few other examples are vanilla ice cream. It's all the same all the way through. Kool-Aid. Basically the first scoop and the last scoop and everything in between looks entirely the same. Now when we get to heterogeneous, it's different. You can see chunks, you can see some inconsistencies, you can see the mixture has bits and pieces of one thing in one part of the sample, and the other part of the sample it looks entirely different, or maybe smells or feels different. So we got some examples of concrete and Lucky Charms and other types of food. For a couple of pictures here. Here we show a heterogeneous mixture of nuts that has been homogenized. So it is possible to change something from heterogeneous to homogeneous by blending it. Let's see. Now, if we go back to that little diagram of our vocabulary, we have mixtures. On the other hand, we have substances. If we have a substance, then it has a chemical formula. So H2O would be a substance. So I'm going to go down to that. The technical definition, it only contains one thing. They can't be physically broken into anything else. The easiest way, again, is to tell if you have an element or a compound is look for a chemical symbol. We haven't dealt much with the periodic table, but we do have all those symbols like H for hydrogen and N for nitrogen. So if you start seeing those symbols, you know that you have a pure substance and it can't possibly be a mixture. Now, as far as what's the difference between an element and a compound, well, an element is just one of those items in the periodic table, and a compound will have a couple of those that are chemically bonded together. So to show you a few pictures of those, this is a picture of a few elements. Looks like we have blocks of silver and powdered something or other. Now, when we get to pure substances and mixtures, this talks about the separation. Pure substances can't be separated. You can't separate gold into anything else or silver into anything else. It's already separated. Mixtures, however, you can separate them. And there are several different ways to separate mixtures. We have filtration, which is just filter. Think of a coffee filter. We have crystallization and precipitation. So crystals can form in a solution, and then we just pull them out, maybe even through filtration. Distillation means that we would boil and collect the steam. Centrifuge uses a spinning device and gravity, and chromatography, you kind of make the colors bleed on a piece of paper. So there's a lot of different neat ways to separate. Here's a picture of a funnel. This is for filtration. So you would have the stuff pour through the funnel, and the filter paper would collect the material. We'll do a lab with that. Here's a distillation, and the heat would boil the liquid and collect the steam in the flask, and all the remaining junk would be filtered out. Here's a picture of a centrifuge. You put test tubes in the container, and it spins insanely fast, so the really dense material settles to the bottom, and the less dense stuff stays at the top. And lastly, we have chromatography. Chroma means color, and graph means write. So you literally put a dot on a piece of paper. You can even use coffee paper, and then if you put it in the correct liquid, it will separate it into its separate colors. So we are now on to the phases of matter portion of the notes. For the phases of matter, we have solids, liquids, and gases. Starting with gases, they have no shape or volume. They kind of fill up whatever container they're in. And with liquids, they do have a definite volume, but their shape can be any shape. The big thing is their particles are much closer together than gas. And if we get to solids, technically the particles do vibrate, but they're so tightly packed. And just to show you a few pictures, here this would be a picture of a solid, where the particles can just barely vibrate. Here would be a liquid where there's some movement, and then here's a gas. And it's kind of odd to think that you could have a spoonful of liquid, and then if you let it go to a gas, it will fill up an entire room. So the volume of a gas can be very drastic. Now, here's a little chart that shows our different terms for changing from solid to liquid to gas. And And those are all terms that you'll need to know quite well. The two that might be new are sublimation and deposition. It is possible to go from a gas to a solid and back, entirely skipping the liquid state. An example of deposition would be when you get ice on your windshield in the winter. The liquid in the gas, the water in the air suddenly freezes and deposits on your window. And sublimation would be when you open your freezer in the house. You can see all that moisture. It's going from a solid in the freezer to a gas in the kitchen because the temperature is so extreme in the kitchen compared to inside of the freezer. Now, one state of matter that we kind of don't talk about, it's 90-something, 97 or 99% of the universe. And if you like it, study astronomy, but it is plasma. So all the stars and lightning and the sun, all that stuff, those are all plasma. So most of the universe is plasma. Chemistry is focused on that tiny, 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 tiny portion of the universe. All right. Now, pure substance, back to that, we can break it down to atom or compound. So those are the two smallest portions of an element in a compound. I believe that is it for our notes. Oh, no, wait, there's a few branches of chemistry. There's organic, which would deal with just the nonmetals on the periodic table. You guys will learn where those are later. Inorganic covers more of the periodic table. And then we have biochemistry.
Good afternoon,
and
Hayden
physical
West.
chemistry.
We have a few announcements today.